adding and subtracting rational expressions, considerably more complicated than multiplying them. And that's because we have to have like terms in order to add and subtract. Like terms require that the denominators be the same. So we're going to look at some where the denominators are the same. That will be very quick and easy for us. This is where the challenge comes in, when you have to find the common denominator. So we'll practice with just some straightforward problems. If we have the same denominator, we're talking about sevenths, we have 3 sevenths and we have 5 sevenths, then how many sevenths do we have? We just add our, well, isn't that strange? Try that again. There we go. We have 8 sevenths. However, if we have thirds and we have halves, these are not the same. They're unlike terms. However, the good news is we can make them like terms by doing some sort of conversion so that they have the same denominator. So what could we do that would make the denominators the same? We could go to a least common denominator, a least common denominator of, that's a D, and that's a dot and a dot, of 6. If I multiply this by a fancy 1, 2 over 2, and this by a fancy 1, which is 3 over 3, the net result will be a common denominator of 6. So we're talking about 8 sixths plus 21 sixths, which gives us 29 over 6. This is where we're going to have to be really careful that we never try to add or subtract unlike terms. Always get that common denominator. So here we go. This one's easy enough. We're talking about two terms which are over x. So we can say this is 8 over x. Here we have two terms which have the same denominator, x plus 1. So it'll be 3 plus 8 or 11. Addition with like denominators is hardly a challenge. Well, it can get a little more interesting, as it does in this one. We've got 4x plus 3. Now, I recommend to you, in a case where you've got subtraction, that you put parentheses around the other numerator. Why do I recommend this? Because way too often we forget that we need to distribute that negative to both the terms that are in the numerator. If you put it in parentheses, it makes it a little easier to remember that. So we got 4x plus 3, and when we distribute a negative to a positive 2x, we distribute a negative to a positive 1, plus 1. I think, yeah, we have got like terms here, so that will be 2x. And we've got like terms here, so that will be plus 2 over x plus 1. Now, you're not finished yet. If we are simplifying this expression, we look to see whether or not we have a common factor. We could convert to a 1. I think we do. Isn't that true? Then we've got This binomial cancels out with that binomial, giving us an answer of, would you believe it? 2. I love it. I do. I love those answers. All right. Addition and subtraction of rational expressions. 3/8 plus 7/8 gives us 10/8, which would simplify to 5/4. And yes, I do expect you to simplify. 2a's plus 2a's, plus 5a's gives us 7a. How about this one? We have a little problem here, don't we? These are not like. We've got an x and we've got a y. You cannot just add those together. The best you could possibly do would be to say, well, I could take 1/2 out of both of these. I'm not sure that makes it simpler. Maybe it just makes it more complicated. Or you could also express it as x plus y over 2. I rather like the looks of that. But they're all equivalent. Okay, adding these two. Well, it's a problem right off. 3 over 2x cannot be combined with something which is over x, but we can find a common denominator by multiplying this second term by a fancy 1, giving us 2x as a common denominator, and it's 3 plus 10 or 13 over 2x. And that's as simple as we can get it. How about this one? Wow, these look so similar. This one has a positive 1 and a negative z. This one has a positive z and a negative 1. I think I would. Let's try it. I have an idea. Negative 3z over 1 minus z. If I were to multiply the numerator and the denominator both by a negative 1, that's just a fancy positive 1, isn't it? Minus 2z plus 1 over z minus 1, I would have a common denominator when I, let's go to a different color. When I distribute this and this, I will end up with a positive z and a negative 1, which makes this common to this. Now I can just have a single numerator over this common denominator. And that's going to be a negative 3z times a negative 1, which is a positive 3z. And I want you to look at this as a negative 1 being distributed. To both of those, you'll have a negative 2z, a negative 1. What do we end up with? Z minus 1 over z minus 1. What do you think? Isn't this the most elegant answer ever? It's my favorite answer is 1. I just love it. This one is, again, unlike denominators, and we must make them the same. And we do that by creating a fancy 1 that will give us a common denominator. Our least common denominator here is going to be 5x. The x was missing, so I multiplied by a fancy 1 composed of x over x plus, I'll use another fancy 1, but this time what's missing is the 5, so it'll be 5 over 5. Now we have 6x plus 3 times 5 is 15, all over 5x. And do I have any common factor I could factor out? No, I don't. I do have a 5 as a factor here, but it has to be also a factor of 6x, which it is not. Add or subtract these. Again, oh, we don't have a common denominator. All right, so what is my least common denominator? Now, you're going to notice these least common denominators can get a little complicated. This is going to be one binomial times the other binomial is the smallest common denominator we can find, which means that we're going to say 3x times what's missing here, and what's missing here is my x plus 3, plus 2 times what's missing in this one, which was x plus 2, and that's all over the common denominator of x plus 2 times x plus 3. Now, I've been cautioning you not to multiply until you try factoring. However, when you get into this situation, you have no common, you have terms, something being added to something else. There's no way you can do any canceling when you have terms. You have to have factors in order to cancel. So we are going to have to distribute and distribute, and then simplify this numerator. We won't do anything for a while with the denominator. Hopefully, as we get towards the end of this, we'll be able to do something. So my denominator is staying just the same, x plus 2 times x plus 3, while I distributed my 3x to get 3x squared and 9x. Now I'm going to distribute the 2 to get 2x plus 4. I'm going to simplify that because I have these two common or like terms. 3x plus 11x plus 4. Oh, that's x squared. Sorry, forgot that. Forgetting that is a big deal. Now, can we factor this? The only factor I'm going to care about is getting an x plus 2 or an x plus 3. I don't have a common monomial, unfortunately. So I'm looking at a positive 3 times a positive 4, or 12. Are there any factors of 12 which, when I add them up, will give me 11? Let's see. I could have 1 times 12, which when I add them up would give me 13. I could have 2 times 6, which when I add them up will give me 8. I could have 3 times 4, which when I add them up will give me 7. And that's it. So what do I know about this? This is prime. It cannot be factored. So That's the best we can do. There's no more simplification I can do with that one. Let's try this one. Here, our least common denominator, again, is going to be one denominator times the other. Fortunately, one of the denominators is just a monomial. Makes it a little bit simpler. So I'm going to have 4 times the missing part, which is x plus 1, minus 1 times its missing part, which is the x, all over the common denominator. Unfortunately, I can't cancel these out because you cannot cancel when you've got terms. You have to have factors. I'm going to have to work with this one and see what we can come up with. We're going to get 4x plus 4 minus x all over x times the binomial x plus 1. This will simplify because we've got like terms, and we'll have 3x plus 4 over x times x plus 1. Do you see any opportunity for simplification here? Is there anything we can factor out of here? We can't factor out an x, so x is out of the question. And therefore, we'll never get x plus 1. So this is the best we can do for simplification. See you back in class.